Up until now, every function you've written has had a name or an alias stored in a variable so that you could reuse it later. A true anonymous function has no name and no alias. It's written in place directly where it's needed, executed once, and immediately discarded by the computer's memory. Let's look at an example where an anonymous function has been stored in a constant under an alias. As you may recall, arrow syntax means that this is our parameter. Our arrow replaces the function keyword, and then this is what's being executed when we call this function. So we have two examples here where we have reused this function by using this alias to call it and passing in the sector name. What if we were to execute the function only once without giving it a name? We would need to start by putting the definition in parentheses, and then of course we would call it with some sort of value. So we'll say sector beta. So let's move a copy of this with a parameter, the arrow, and the code that it executes, and put that right inside those parentheses. This probably looks pretty strange, but we have a valid function definition right there, and this will allow us to call it. Let's run it. We see internal scanner pinged at sector delta, and then at sector alpha, and at sector beta. So all three of these lines executed. You might be wondering, why would you do this? Why would you define something once that you might want to use again with other values like we did up here, where we stored it in an alias? And the answer is you wouldn't. If you want something reusable, you need to either use the traditional syntax or do just like we did here, where we give it an alias and store it in that constant. So what is a good use case for defining an anonymous function in place? Let's consider this situation. We have an anonymous function that has been stored in this constant blastoff. And not only are we only going to run it once, but we also don't want it to run right away. We need to wait a few seconds. So we have this log here, initializing countdown sequence 3, 2, 1, and then we want this to execute. So I could certainly use this named function as it is, passing it to a function called setTimeout. SetTimeout is something that's built into JavaScript. You give it some sort of function as a reference, and then you also give it the delay time in milliseconds. And then it will wait that amount of time to actually execute the function that you pass to it. So I will call setTimeout, pass it my function, blast off, and then for the second argument, give it 3000, which is milliseconds. That's the equivalent of 3 seconds. Let's go ahead and run that. And we see that it took 3 seconds for this very last line of code to execute. That's what setTimeout will do for you. However, we also said that this is something we only really need to do once, so there's no point in storing it in a constant. We can just pass it to setTimeout with the definition written in place, and then it will be removed from memory as soon as it has been executed. So let's try this again. And this time, we'll have our second argument there with this 3000 milliseconds, but right here is where I need to put the definition of my function that I want executed only once. And that's the entire thing, from the empty parentheses where we don't need a parameter defined, to the arrow, and then to the code that's going to be executed eventually. So let's go ahead and run this. And remember, we're calling this twice because we have the one we passed with the named constant, and then we also have the one we defined in place. So it's initializing countdown sequence, and then notice that both of those executed almost exactly at the same time. That's because out here in the global scope, these execute immediately. And what you have then is what's called a race condition, because this is going to execute after 3 seconds, and so is this one defined right here. And it goes so fast that they essentially end up executing at the same time. Let's do something interesting here. I'm going to change this one to 5 seconds, and I'm going to change the way this is written just a little bit and say, we have liftoff. Let's run it again so we can see the order in which these execute. 3, 2, 1. There's our second one, and there's our first one. So what we saw was that this one executed after 3 seconds, and this one executed after 2 more seconds for a total of 5 seconds. We have proven that you can take this anonymous function and never name it. We aren't storing it in a constant or anything. We just define it in place and pass that to setTimeout so that it can execute it after this amount of time. This is a very common pattern, and we're going to look at more of them as we get into special array methods. Going to make a quick git commit here. And let's take a look at the practice. You'll have an opportunity here to write a couple of nameless single-use arrow functions directly in place using setTimeout, and this will give you some good practice using these concepts. That's all I've got. I'll see you in the next one.